So now we'll turn to looking at periodic signals in continuous time. So we'd like to know what a periodic signal is and determine if a signal is periodic or not. And then if it is periodic, find the period and what's called the fundamental angular frequency of the signal. So a CT signal x of t is periodic if it repeats. That is, if it repeats every t0 seconds, and it's periodic with period t0. What does that mean mathematically? That means x at time t plus t0 is the same as x at time t. So it's just identical to itself at t0 seconds in the future. The smallest such t0 is the fundamental period of x of t, and that's the smallest t0 for which that is true. So if it repeats itself every 2 seconds, then obviously it already also repeats itself every 4 seconds, but you would really say the fundamental period is 2 seconds. And the fundamental angular frequency is 2 pi over t0. The 2 pi comes because we're talking about radians. If you wanted to talk about fundamental frequency in hertz, it would just be 1 over t0. And if a signal is not periodic, we call it aperiodic. That's a little bit of language. So for sinusoidal functions, it's pretty straightforward to figure out the periodicity. We just look at the part multiplying t. So this phi, the phase shift in this cosine omega t plus phi, the phi doesn't matter. The a, the gain, doesn't matter. And so we just have to figure out if the fundamental period is given the fundamental angular frequency. The fundamental angular frequency is omega, so we just take 2 pi over omega. Let's do some examples. It'll make it pretty clear. This is fairly straightforward. So if we have 3 cosine 120 pi t, we take the part multiplying t, which is 120 pi. We take 2 pi over that, so 2 pi over 120 pi, and we get 1/60th of a second. So every 1/60th of a second, this signal repeats itself. What about for x of t is equal to sine 0.14 pi t plus 2 pi over 5? Again, we can ignore the phase shift, so this 2 pi over 5, we don't care about it. We just look at the part multiplying t, which is 0.14 pi. Take 2 pi over that, and then multiply top and bottom by 100. You get 200 over 14, so 107 over 7. So the fundamental period is 100 over 7 seconds. It repeats itself every 100 over 7 seconds. What if we have 2 or more sinusoids? Well, then we have to analyze them separately and try to put them together. So the first signal repeats itself every t1, which is 2 pi over omega 1 seconds, and the second repeats itself every t2, which is 2 pi over omega 2 seconds. So what we want to have happen is that there be 2 integer multiples of t1 and t2, such that they then line up again. So the picture you should have in your mind is something like this. Here's t1, this is another t1, this is another t1, and then 4, 5, 6, 7, 8. So then we have this is t2, so we'd have 8 t2 and 3 t1, and they line up with each other, so that it takes 3 cycles of the first one and 8 cycles of the second one to get up to the same time. These two things are equal. So then t0 is equal to 3 t1 is equal to 8 t2. So if you can't find integers, like 3 and 8 in this example, such that they line up again, then the signal is aperiodic. Looking at a little picture of this, we have cosine 4t and cosine 3t. They have different frequencies. You can plot them on the same plot and they look a bit different. When you add them together, you get this more differently wiggly function, and that's the sum of the 2 cosines, and looking at it, it looks periodic. So that gives us a sort of general recipe, which is to first you can try drawing a picture of the signal to see if it looks periodic. Looks can be deceiving. So for example, there could be some slight jitter in the time axis, it's slightly off, it doesn't quite repeat itself. And that will show up in the math, but it won't show up in the plot necessarily. But you can look at the plot to try and make an educated guess about what the period might be, or at least whether it's periodic or not, and then you try to verify your guess mathematically. You have to actually do out the math and prove it. So let's look at 3 more examples with the sum of 2 sinusoids. So cosine 3 pi t plus 2 sine 18 pi t plus 5. We can ignore the 2 and the 5, the phase shifts, because remember, they don't matter. All that matters is what's multiplying t. So we have omega 1 is 3 pi and omega 2 is 18 pi. So t1 is 2 pi over 3 pi, which is 2/3, and t2 is 2 pi over 18 pi, which is 1/9. But note, actually, that 2/3 is just 6 times 1/9, so it takes one cycle of the first one, and it takes 6 cycles of the second one to get through one cycle of the first one, so it's periodic with period 2/3, which is the same as the period of the first one. What about cosine 3 pi t plus 2 sine 17 pi t? Well, again, we have t1 is 2 pi over 3 pi, which is 2/3. t2 is now 2 pi over 17 pi, which is 2/17. And here, since 3 and 7 are relatively prime, we can't really do very much with each other, so we just go through 3 cycles of the first one and 17 cycles of the second one, so it's periodic with period 2 seconds, which is 3 times 2/3. What about cosine 3 pi t and 2 sine 12 t? So the frequencies are 3 pi and 12. So we get t1 is 2/3 again. t2 is now 2 pi over 12, or pi over 6. But because of the pi there's no integer multiple of t1 and integer multiple of t2 that are equal to each other, because pi is irrational. So this is actually an aperiodic signal. So adding 2 periodic signals can give you an aperiodic signal. So as an exercise for yourself, try and analyze some of these. So we have an absolute value of cosine, and we have some complex exponentials, which I think if you can Eulerize them, you'll get something that you want. And then try to make up some of your own, because I think this is a topic which, just as you get a little bit of practice with it, you can understand it a lot better.